it's Todd from Todd's Workshop and Todd Cutler here. I've built this amazing Chinese siege crossbow and it does this. Yes! That was just amazing to see. It just went like a laser beam straight through those melons. Just absolutely fantastic. But anyway, enough of that. We're going to get more of these glory shots through the film. Clearly, this has been rebuilt since the last time you saw it. So it was an early stage prototype before, just looking at the layout, and now I've built it properly so we can really make this thing work. And if you want a good guided tour of this, you'll find that on the second channel, Todd Cutler. But at the moment, we're just sticking on actually shooting the thing today. I can tell you that this is one crazy machine. It's one of the craziest things I've ever made, and I have made some bonkers stuff before. But now we are going to go out and use it. So it's time to start shooting things, finding out what it can do. But like all good relationships, we need to set our boundaries, we need to introduce each other. So, machine, I'm Todd, you are... no name. Sort that out in the comments, please. I want suggestions, and it needs to be good. So let's start our relationship with two simple questions. What weight bolt should it shoot, and how far will that go? Now, obviously, a light bolt is going to go further than a heavy one, and it's hopefully going to outrange other hand artillery types like regular hand bows and things like that. Gives you a great advantage. But then we have the heavier ones. They're going to do more damage when they hit. They carry more energy, more momentum. So there's arguments for using both types. But the thing is, if you go too light on an arrow, it damages the bows. And it's a bit like if you or I throw a small stone really, really hard, it can end up wrenching your shoulder. You don't want to wrench these bows apart. So we're going to shoot our bolts and we're going to get speeds off them. That's going to allow us to get momentums and energy. We can have a look at that, see where that fits into our concept of this weapon. But then, of course, the last thing that we absolutely have to test for is distance. Now, the thing is, I could have used a ballistic calculator, but I'm just not that kind of guy. I'm this kind of a guy. So we're going to do that and we're going to see how far they go. So our first bolt is a monster 260 grams. Don't really want to go any heavier than this. I think we'll start to lose advantage, but who knows, we might end up that way. Okay. Loose! Oh, that was quick though. That was nice. So we got ourselves a thigh shot here, heaviest bolt. So we'll actually leave the elevation exactly the same and we'll see where they go. But I can tell you the speed was 55.3 meters per second. And yeah, just straight out the back of that. And whoa, look at that. So that's a couple of people they've connected forever. 220 grams. And loose. So speed on that one, 59.6. So again, that is fast for any kind of bow. But just check this out. So we didn't quite Robin Hood them, but my goodness. So the second shot was just an inch, 2 centimeters above the first. It's accurate. It's going to give it a slight bit of elevation because what I don't want is to hit that other bolt. And loose! God, this is so tasty! And for ancient bow technology, a stunning 68.4 meters per second. Goodness me. Oh, okay. Look at that, straight through a bit of, what's that, 70mm thick wood, straight through it. And you can see it coming out the other side here. I don't know how far it's gone in. Oh, and that as well. What a shot. Oh, and of course, that far away from our poor little long-suffering GoPro. Although that's number 10, not the 10th one, but I think it's my 4th one. I know it's what, it's 25 meters, but bang, bang, bang. They're in a width of that. That is just fantastic. That is super, super accurate. So this is something that I've just spotted now that we're about to take them apart. That, of course, is the heavier head. That's the medium head. But they both hit 6mm ply and then this. So, in fact, you can see its ability to penetrate on the heavier head is, well, 2.5 inches, so 70 millimeters more, something like that. So it's just phenomenal to be able to do these things and see these things, and it just excites the heck out of me. But we've got some numbers now that I can share with you. So we've got 3 bolt weights, 260 grams, the biggest one. That's giving you a velocity of 55.3. That's really big. That's a big velocity for bow world, or at least for ancient bow world. Obviously modern ones go faster now. Kinetic energy, 397 joules. That is in bullet territory. Momentum, 14.4, similar. That's really big numbers, especially for a bow. Then we got the slightly lighter one, 220 grams. Velocity 59.6, massive speed that is. 390 joules, so only just lower than the heavy one. But you're going to get more range out of that. Momentum, a little bit lower, 13.1. Still massively respectable, still in sort of land of bullets, really. And then you've got the lightest one, 160 grams, 68.4 meters per second. Phenomenal speed. 374 joules, so a little bit down on the energy, not very much, and then 10.9 on the momentum. That's sort of significant drop actually, but still a very respectable amount. So altogether, it's going to allow you to choose what kind of projectile you want. And I haven't yet decided. We've got to look at distances. Hi, I've interrupted the film for another Todd Cutler related interesting fact. 14th century Italian warhammer. Now, it's an interesting fact because that should be a fantasy piece. That's what it looks like, but it's not. It really is copied off a real one. Anyway, this and loads of other pieces available on toddcutler.com. Back to the film. So to recap, for any people who don't know what this is, it is an ancient Chinese siege weapon. At least 1,000 years old, maybe 2,500 years old. And it's characterised by 1 bow at the back and 2 at the front, facing in different directions. That's what I've done here. But as you can tell from the sketch, there is so little hard information. I've just had to interpret things. And this is what it is. So the last film that I did on this series, we built effectively a prototype just to lay it out and see if it worked, which it did. And then I've gone through and built this one here. So we have got a draw length of 145 centimetres. I don't even know what that is in inches. It's about 57, something like that. It's got a draw weight of a little bit more, because I haven't rechecked it, a little bit more than 110 kilos or 240 pounds. It's massive for bow technology. So the thing about the Chinese is they love to make things modular. So they have a cast trigger system and they have what are effectively hand bows built into this system here. But this one has stopped at 100 pounds on the front and 80 at the back. But looking at this layout here, I'm thinking I need to increase the power of the back one. So I think we're going to jump that up to 100. So power is only going to go up from here. But talking of power and going up, let's shoot for distance. So getting ready for our first shot, 260 grams at 40 degrees. Yep. And loose. Whoa! Nice. Lovely, and down. That was good, but heavy. Good, but heavy. So now we're going to do 220 grams. I love the look of this thing. It is just so very, very cool. And loose. Oh, yes. That is lovely. Lovely, lovely, lovely. Right, time to do another. So 160 grams, this one. So it's our lightweight boy. Not very keen on the clicks and pings. No. There is, for the record, about, well, nearly a metre between the bow limbs. So we could shorten this thing down. And loose. Oh, I can't even see it. I've lost it. It's gone. Gone, gone, gone. So I've just reviewed the slow-mo footage, which you have just seen yourselves. Clearly that bolt is not being thrust directly from the back. I'm not sure if the other ones were like that as well, but we've got to have a look at that. One of the beauties of slow-mo, it allows you to really see things, but that's not right. So we're going to come back and have a look at that, but bear that in mind when we start talking about distances. So our first shot has just come in at 234 meters. Next one coming through at 252 metres, and the farthest one, the lightest, 160 gram, 295 metres. Now, the thing about these machines is they made all sorts of fanciful claims about them, which I would say even before doing this were clearly bunkum, that they could shoot spears so powerfully into brick walls that you could climb up them and use them as scaling ladders, that these things were so powerful you needed 800 men to load them. Whatever it is, quite clearly rubbish. But has this performed quite as I wanted it to? No, it hasn't. Has it been absolute fun doing it? Oh my goodness me, it's been absolutely brilliant. Scary. I find it a little bit scary, I must say. So we'll study the slow-mo, we'll see if we can get rid of some of the weirdness of the launch, try and improve things from here. So I hope you've enjoyed this one, seeing really what it can do and putting it through its paces. But there is going to be so much more to follow. So if you don't want to miss out, make sure you subscribe, because there's going to be, oh, I don't know, storms of crows, incendiary arrows, multiple bolts. I don't know. You suggest. You let me know what you want to see and we're going to go do it. Don't forget we've got another channel, Todd Cutler, with more niche content. And of course, we've got our website, toddsworkshop.com, where you will find all sorts of stuff that you will be interested in.